مش هن بيعتمدوا على بعض.
Yes انتبه
يعني خدهم فيها ما ناخدهم ما هيك.
انتبهوا على شغله حسب البروبلم. يعني مثلا هون for the angular velocity W of the blades, okay, it is of course it will be related to you, but maybe not by directly a proportional relation. يعني sometimes if you have, for example, a flow over a cross section like this, for example, you can directly say that the mean velocity inside is equal to, so if I determine, if I have a rotation omega, let's say here for a circle, I have rotation, omega is given, and then I want to find the velocity, I should multiply by the radius, for example, to find the velocity at the periphery. So here we have directly a proportional relation. Here it's little bit more complex, yani the relation between the rotation of the turbine and the velocity of incoming air is not a straight proportional relation. So you need to correlate if you want. It will account for a different variables, because here for turbines it's very complex. You should apply fluid mechanics in order to relate the W and U. It's not a straightforward relation. Okay, and anyway, whenever they cite for you a variable, even if they can be correlated, you should use it. In a problem, if they tell you I want this as a parameter, you should include it. If they don't tell you, like I told you last time, they gave you a fluid, they didn't specify what variables should be involved. But when we made the analysis together, we said because W is already here, no need to put the velocity. Okay, because in the previous problem we did, the relation between W and U was very straightforward. Here it's not the case. Okay, so I should include both parameters, W and U. Okay, so these are the variables involved in my. نعم.
السؤال هو انه طب نحن كيف حنعرف depends on the question. يعني مثلا هون ال W انه ما خاصه بالفي، الفي اللي بالاحرى اليو.
Depends on the question, exactly. They said that we have the angular velocity of the turbine involved plus the velocity of air. Yani here you have a relation between U and W, but you don't know what is this relation directly. This is why you should involve both parameters. Okay? And anyways, I told you that you should use this variable. Yani here it's not for you to determine what are the variables. You have them. And the other problems, they didn't give us the variables. This is why we did a small analysis to determine what are the variables involved. And as I told you, even if you include U and W, it's not wrong. You will obtain an additional group. But the idea is if they are directly related, no need to put the two at the same time. That's it. But it's not wrong if we put it. Okay? So now, these are my variables.
Doctor, can I ask one question?
Yes, sure.
Why didn't we use mu هون؟ ولا لأنه it's not part of the given?
Exactly, it's not given. Because they didn't give you in the list of variables, you do not include it. But sometimes if they just tell you we have a flow and we want to, we have a flow in the problem, they didn't mention what are the variables to take. You should take rho, U, and mu. But
so by random by random
يعني انت عادة لانه البروبلم هون قال لك الفاريبلز، يعني هول الفاريبلز included. هلا in general mu should be included. It's right. But for this particular application بيكونوا هن عارفين انه mu is not important. This is why they didn't tell you to include the mu. Okay? But in general, if they don't give you the variable and you have a flow field, put rho, U, and mu. Okay?
اوكي واذا ما عاطينا وبس عاطينا دبليو، فينا نشيل اليو مع الدبليو، يعني اليو فينا نحط الدبليو محل اليو. اذا ما عاطينا شيء.
Yes, because in case they are directly related. Yes. هلا هيدا البروبلم توربين انتم اخذينا، ما بعرف اذا اخذينا قبل التوربين، يعني it's very complex. مش انه اذا عندي الفيلوسيتي U directly I determine W. It's a complex relation. مش مثل ما اقول مثلا عندي rotation of a fluid. If I have rotation of a fluid at omega, then I can say that U is omega times R. But here it's not the case for the turbine. It's different. Okay, لأنه عندي flow over the turbine and the lift with drag forces, and due to lift forces I will have rotation. يعني the relation between omega and u is not explicit, it's a complex formula. This is why they are ما فيني احطهم دغري انه directly related to تنشيل وحدة منهم. Okay, so these are my variables. Now I determine their dimensions. First, for the number of blades, the number of blades has dimensions. Do I have dimensions for the number of blades? No. يعني no dimension. Okay. If it doesn't have dimension, what do you think? Can I form a group with it?
No.
يعني هي by itself is a group. You can say that n constitute a group by itself. So directly, because n is without dimension, this is your first group. N is my first group. This is pi 1. Okay? Because if I have a variable without dimension, this means that it constitutes a group by itself. So one condition, if you want, between the prototype and the model will be to have the same number of blades. Now, I continue with the other variables. For the power P, what I advise you to do for the exam, since it's an open book, you have common variables that you face in problems: power, force, let's say angular velocity, etc. What I advise you to do is to put them on a paper and put their units. In this way, in the exam, if you have such variables, you don't have to go back to your notes or to remember what is the unit. Okay. Anyway, if you forgot the unit and you cannot find it, you can simply remember what is power. So power is energy per unit time. It's energy over time. And energy is what, by definition? Energy is force times distance. So I have force times distance over time. Okay? And for F, what is the unit for F? Who remember? So force is mass times acceleration. Okay, so the dimension is m times L t minus 2. Okay, over t square. Okay, now I want to multiply F by D, so I get the unit of F is here. This is ml over t square. Okay, I will put it again here. And the unit of D is length, so it's times L. And finally, for time, I'm dividing again by t. So as a result, I will obtain ml square over t cube, okay, over t cube. So this is the unit of power. Now for the diameter, it's very simple. It's L. For omega, remember that the angular velocity unit is what? For the angular velocity, the unit is radiant per second.
T minus 1.
So I have radiant is without dimension. So I have only 1 over t. And for rho is the density. For the density, it's kilogram per meter cube. So it's ml minus 3. And of course, for velocity, it's meter per second. So it's lt minus 1. So now I am done with the dimensions of my variables. Now I can start to determine how many groups do I need. Okay. So first, to determine how many groups do I need, I count my variables, 1, 2, 3, 4, 5, 6. So n is equal to 6. Second, to determine what is j, I have, what are the dimensions involved here? M, L, and T. So the number of dimensions involved is 3. So j is equal to 3. So I deduce that the number of groups should be, can be equal to 3 if j is 3. Remember how to make sure that j is 3. I should find 3 variables that are independent. And if you remember, one of the technique I told you to use to determine independent variables, you can try to choose 3 variables, for example, where one contain only m and the other contain only t. So in this way, they can never form a group. So for example, here, if you look, if we take, for example, rho, u, and d. Okay, why I can be sure that they cannot form a group? Because rho is the only one containing m. and U is the only one containing T. Okay, so now I am sure that rho, U, and D will not form a group. And remember also
Can you check
another
the
method.
chart?
Yes.
Can you check the chart?
Sorry, I cannot hear you.
Can you check the chart, please?
Yes, I will check it. 1 minute. Can we take P, D, and omega? Yes, of course. Just let me make sure. P, D, and omega. Yes, you can take them, but because look, P is the only one containing M. Okay, and if you combine it with D and omega, it's not straightforward because look, you have T and omega and P. But if you try to form a group between P, D, and omega, you will not be able to do it. So yes, you can take P, D, and omega. But the other one is more straightforward because omega contains T if you want. Okay, but if you combine these
فينا
three.
ناخد رو دي اوميجا.
فينا ناخد رو دي وأوميجا كمان فينا ناخد. Yes, exactly. كمان we can, of course. You can take rho d and omega because rho is the only one containing M, omega is the only one containing T, so any combination of them will not form a group. Of course, yes, you can.
دكتور لما نقول انه this variable contains only مثلا M او T
بغض
النظر عن the power, right?
Yeah, of course. بغض النظر عن power.
Okay.
Yes. Okay. So even the suggestion P, D, and omega will work because if you try to combine them, M can never cancel out, okay? And even if you use, let's say, PD with omega for any combination, you cannot cancel M. Of course, they cannot form a group. بكفي if you want, and if you include P with them, you can never form a group. And between D and omega also, you can never form a group. Because between D and omega contain only T and D contains only L. So of course, no group can be formed with PD and omega. So also it's a possible choice, okay? But if you want in general, when you have two questions, what I advise you to do is to read the two questions. So here, for example, what we want to determine at the end, if you read question B, okay, you need to determine for the prototype what will be the power of the prototype and what will be the angular velocity of the prototype. So if you read this question, this will help you into selecting your variables, because what are the outputs you need to find? Your outputs are power and angular velocity. So try to not include your outputs in your variables. So this is if you want a general technique, because if I do an experiment, my final purpose is to measure the power and the angular velocity. That's why in this case, I will put them as outputs, not as inputs. So the independent variables in general, we choose them as parameters to vary in the experiment. So rho UD, I can vary them, and my output will be power and angular velocity. So from question B, this question can help you to say, I will not take P and omega in the independent variables. I will take them as outputs, so they will form my pi groups. Okay? So what I will do now, anyway, and it's not wrong if you take them, but it's better to keep them as output. Okay? So now, what I will do, I will select rho UD as independent variables. Okay? And now I am sure that what is the number of my group? Yes? Yes, tell me.
بس can you repeat the last sentence إنه كيف ساعدنا part B لنعرف أي
Yes, I will.
variables?
Yes. Look, when you do experiments in general, when you choose independent variables, okay, you can say that these variables can be varied in the experiment. So let's say I can vary rho, U, or D, and I want to form a group. When I form a group of rho, U, D with P, this means what? This means that I will express the power P as a function of the other variables, okay? So when you put P as function of rho, U, and D, this means that you are measuring P, and P is an output. This is what I mean by this. An output means that I will express power function of the other variables. And the same for omega. When I don't use it as independent variables, I will express it function of the other variables. Okay. Part B, in part B, they ask you that if I know that the model turbine is diameter is 0.5, the angular velocity is like this, etc. I want to measure at the end. What was the question? What will be the power? What will be the power? And what will be the angular velocity? Yani from the question, it's an implicit way to say that my output are power and angular velocity. So I want to try to express P and W function of other variables. Okay? So this is why I will choose them as external variables, yani to form a pi group with them, not to be one of the variables, independent variables here. It's not wrong. No, you will obtain a result if you put them as independent variables. But in this way, it will be more straightforward. Yani instead of including them in several groups, you will only find one group including P and one group including W. So now, when in the second step, to find power, you say the pi group of P for the first one is equal to the pi group of P for the second one, instead of obtaining a complex system at the end. Okay? Clear? Any other question on this? Okay. So now, after we choose the independent variables, we determine the groups. To determine the groups, it's the classical method. What should I do? First, I take P. To form a first group, I will take P. Okay? Because look, N is already a group by itself, and we selected the independent variables as rho, D, and U. So we still have only two variables. We still have P and W, okay? The power and the angular velocity. So first we will form a first group with P, then we will form a second group with W. So first, to find the group of P, we say that the group 2, if you want, لأنه قلنا N is the first group. Group 2 is P times rho to the power A, U to the power B, and D to the power C. Now, to determine what are the coefficients A, B, and C, all we have to do now is to put the unit of P, the unit of rho to the power A times the unit of U to the power B times the unit of D to the power C should be equal from the other side to what? Because it's a group, no dimension. So it's equal to M to the power 0 times L to the power 0 times C to the power 0. Okay? And now, if you do your expansion, what is the total coefficient of M? The total coefficient of M, here you have M to the power 1. Okay, and here you have M to the power A. So 1 plus A should be equal from the other side to what? To 0. So this is my first equation. My first equation, I get it from the coefficient of M. So from this analysis, I can deduce that A is what? From the first equation, A is -1. Now, the second equation is from the coefficient of T. Okay? So what is the coefficient of T? From the left side, I have first T minus 3, and here T minus 1 to the power B. So minus 3 minus B equals to what? From the other side, the coefficient of T is 0. So my second equation is here from the from the coefficient of T. Minus 3 minus B equals to 0. So B is equal to minus 3. I still need to find C. So to find C, I use the third, the dimension of L. Okay. What do I have from the left side? For L, I have L squared. So 2. And here, minus 3 to the power A. So 2 minus 3A. And I still have L to the power B. So plus B. And L to the power C. So plus C. So in total for L, I have 2 minus 3A plus B plus C from the left side, equal to from the other side to 0. So this third equation, I already got A and B. I replace A and B, I get the value of C. Okay, so now from this system, I have 3 equations, 3 unknowns. I found what is the coefficient C, A, B. What are the coefficients A, B, and C? Once I find A, B, and C, my group is done. Okay, because A is the coefficient of rho. So since A is -1, so it's over rho. B is -3, so it's over u cube, because b is the coefficient of u, and c is -2, so the coefficient of d, I have 1 over d squared. So in total, the first group or the second group is p over rho u cube d squared. Okay, I am done now with the group of p. I move to the group of what? Of w. So now I will take w with the other variables rho, u, and d. So now, same technique, I repeat the same thing now to find what? To find the coefficient a, b, and c. I write 3 equations, 3 unknowns, 1 for the coefficient of m, 1 for the coefficient of t, 1 for the coefficient of l. I get a, b, c, and then I can form my group. So my second group is omega d over u. Now, always, when you finish, make sure that your group will work well. How you can make sure? The unit should be no unit. Okay, let us make sure here, for example, w is radian per second, so it's 1 over t times d. What is the unit of d? It's L, so it's 1 over t times L over what? Over the unit of u, which is L over t. So I have the same unit. Guys, please, can you mute your microphones when you don't ask questions, please? So here I can simplify because this is L over t and this is L over t. So I made sure that this will not have a dimension. And I can do the same for the group of P to make sure that it will not make any dimension. Okay. Now, once I have my groups, what is the next step? Now I can answer the second question. Okay. In the second question, they gave me all parameters of the model. They gave me the diameter, the omega, the power, the density, and the velocity. Okay. And now all I have to do is to find, for the prototype, they only gave me the diameter, the density, and the velocity. And I will find the 2 remaining variables, which are the power and the angular velocity. So as usual, whenever I have a model and a prototype, the condition to be applicable is that the pi groups should be should be the same. Okay. So here, since I have for the number of blades, as we said already, it should be the same because they n form a group by itself. I still have 2 other groups that should be equal, which are the power and the angular velocity. So I will write the condition that first, so these here we have the summary of all variables. You can put them, model and prototype. I should determine these 2 conditions for the prototype. So now, if I take the first group, the group of angular velocity omega, I have that omega d over u for the model should be equal to omega d over u for the prototype. Okay. And now I have all my variables, but I don't have omega p. So the only unknown in this equation is omega p. I can get it. If you want, no need to convert units, but I want to tell you, if you use omega in revolution per second for the model, it will be in revolution per second for the prototype. If you use it in rotation per minute for the model, it will be in rotation per minute for the prototype. So just pay attention to have for omega same dimensions, for d same units, I mean, and for u same units also. Okay. Now, the next step is we found the omega prototype. The next step is to find the power of the prototype. So now I move to the second group. The second group is for P. We have found together that the group is P over rho d square u cube. So all I have to do now is to put that P model over rho model d model squared times u model cube is equal to the pi group of the prototype. And I replace my variables. The only unknown is P of prototype. And as I told you, since P model is given in kilowatt, then your result for the prototype will be also in kilowatt. Okay. Any question for this problem? Okay. So now let me move.
Doctor?
Yes.
شو عندنا examples of dimensionless variables يعني هون مثل number of blades مثلا شو ممكن يجي غير شيء؟
في كتير examples. The frequency. The frequency هي in hertz. Okay, so it's without unit the frequency. Okay.
frequency مش هي 1 over time.
يعني بأي معنى يعني you have for example
إلزو كمان
over second.
التليفون
Hertz.
بالسكرين تبع اللابتوب تما تبين.
Mark. Okay. Look, for example, if you have 1 second, just someone is entering the meeting. You have, for example, لحظة الفريكونسي let me check قلنا الفريكونسي no sorry مش الفريكونسي is 1 over the period صح؟ Yes, so it has a unit of frequency. Example of something without unit. You have the angle, okay? If you have an angle in radian, so this is without unit, okay? So if I give you an angle theta, so if you have theta in a problem, an angle, no unit for it, okay? What also? So if you want any number, so if you have, let's say, a number of blades, number of, if you have any problem, a number of objects, so any number that is not representing a certain dimension will be without unit. The angle we said it. What I don't, now I cannot remember anything else. But you have, for example, epsilon in materials. If you have by definition, the deformation epsilon is delta L over L. Okay, so it represents the variation in length over a certain length. So the unit is L over L. So it's without unit, L over L. So no unit. Okay, so it depends. Yani, if you have any variable that you don't know, you can just check it because you have open book here, and you can just check it in the internet to know what is its definition. From its definition, you can know if it has a certain unit or not. Okay. So that's it. Mainly these are the ones I remember, but you can encounter several variables without units. Okay. So let us continue. Okay. Now we will do a problem on chapter 6. Consider steady incompressible flow between horizontal infinite plates, parallel plates with V equals 0 and W equals 0. Derive an expression for the velocity and pressure profiles and determine the volumetric flow rate and the maximum velocity. So here in this problem, we want to find what is first the variation of velocity and pressure in this problem, and we want to find the volumetric flow rate Q and the maximum velocity for the velocity profile. So first, whenever you have such a problem, the first step is to go to your formula sheet and to use the corresponding equations, okay? Always think about the two equations, continuity and Navier-Stokes equations, okay? So first here they helped me a little bit. They said that V is 0 and W is 0. So they help me in the problem. They can give me, sometimes instead of saying this, they can say, for example, whenever you have infinite parallel plates, when they say infinite, so in the direction where you have infinite plates, you will not have a velocity because you don't have any constraints. So here, whenever they say infinite, you can say that in this direction, where we have the width, in the direction that is in the width, you can say that the velocity, you will not have change in velocity, okay? So whenever, if it's initially 0, it will remain 0, or if it's initially, it has a certain value, it will remain with the same value, okay? And sometimes also, for example, when you have a flow, instead, let's say, of saying, so they can tell you here, for example, they can say U is only function of Y. They can tell you this. if they say, for example, u is only function of y, so directly you say that the, u is independent of x. Okay. Another way to say it is to say that you have a fully developed flow. What is a fully developed flow? Who knows? شو يعني fully developed
لما خلص
flow؟
الفيلوسيتي تاخد
لما الفيلوسيتي
تاخد
profile
بروفايل
إيه؟
معروف.
لما البروفايل of velocity will not change anymore with direction of motion. So here let's say I have flow moving. I have a flow moving in this direction. Okay. So if I start from the inlet first, the flow will vary, but after a certain distance, okay, it will become developed. What we mean by developed flow, the profile will not change anymore. So I will have the same profile at any section, same profile. This means what if I have the same profile? This means that my flow will be independent of x here. Here the direction of motion is x. So when they say fully developed, it means that the flow is independent of the direction of motion. So here I have a flow along u. So the u flow will be independent of x. So it will be only depending on what here? It will not be depending on z here because it's we have infinite. The flow is infinite along z. Okay, so it will only be depending on y. Okay, it will only be depending on y. Now, how we can make sure of this? So here they didn't tell us fully developed, but we can deduce this. How we deduce this? If we go to the formula sheet, okay, the formula sheet will allow us first for the continuity. From continuity equation, what do we have? Let me open the formula sheet. 1 second. Do you see the formula sheet now?
Yes.
Okay. So from the formula sheet, first, if you look at the continuity equation, we will start by applying the continuity equation. First, here we are not in polar coordinates, we are in Cartesian coordinates. Okay. So please always in the problem, always write them. Even if you know the solution or it's straightforward, write the equation and simplify it to get your result. So here it's a 3D flow, okay, so and it's steady incompressible. So I will use this relation. Now I will start to simplify it. In the problem, so always you should look at the inputs of your problem, and depending on the problem input you select, you should know which terms will be simplified. In the problem here, they told you that V is 0, from the given V is 0, and W is 0. Okay, so from this you can deduce that these two terms will cancel out. Okay, and I will end up only with what? I will end up with del U over del X equals to 0. Okay, so what can I deduce now? I can deduce, so it is a fully developed, it is a fully developed flow. So here, another method to solve this problem, I can tell you it's fully developed, so you deduce that del U by del X is 0. So always look at the given, and depending on the given, you can do your conclusions. So it's a fully developed flow.
دكتور
Okay? Yes.
وقت كنت عم تقولي انه مطلوب نبلش فيها الايكويشن من الاول.
Yes.
يعني مطلوب نبلش فيها من البارشل تي باي بارشل تي بلس هيدي بعدين بنعمل.
هلا you can't say because it's steady. يعني ما هيدي هون you have directly for steady incompressible you can directly write this relation, this one. يعني just you can tell me since it's a steady and incompressible flow, then del U by del X plus del V by del Y plus del W by del Z equals 0. Then since V and W are 0, I can simplify to get only del U by del X equals to 0.
يعني بس بنبلش محل ما نحن محل ما هي يعني اذا عندنا steady and incompressible بنبلش فيها لهيدي del U by del X.
إذا steady and incompressible you can directly apply this. مش ضروري تكتب اللي فوق. No need. فيك دغري تحطه. هلا
Okay, thank you.
يعني مش غلط تحطها اكيد يعني it is better of course if you start from here but you can directly but because انه it's a known relation انه if it's steady and incompressible I can directly write this one. Okay.
هو
Okay.
دكتور في عليهم
Thank you.
partial.
أكيد فعليا partial. So directly from your application put your relation and then simplify terms. Okay.
Okay, يعني use the
Okay.
function of y and z.
You okay. هلا you can say that u is function of y and z but why you it will not be function of z. شو قلنا نحن هون؟ In this problem you have infinite plates in z. Because it's infinite in z يعني it will be independent on z. It will only be depending on y. Okay. يعني it's true that from this you can conclude no it is u is function of y and z. You can say this, but after u function of y and z, but then you will say since I have infinite plate يعني u will be independent of z because I have infinite plate, so it will be only depending on what. Okay. So since infinite, because it's infinite, يعني no restriction in z. I don't have any restriction in z direction, so you will not vary in z. It will only vary in y direction. Okay. So I deduced from this that u is only